Okay, today we're looking at Chapter 4G, independent events. So this is the last little bit of probability, so good job, you've made it this far. An independent event is, so over here, actually let me get my highlighter. Okay, independent events. And when you have two events that do not influence or affect each other. Okay, so a couple of examples of this could be something that will happen and it doesn't influence the thing that happens next. So let's say I roll a dice or a die, roll a die, and I get a 6. Will that change if I flip a coin and get a head? Does me rolling a 6 affect the fact that I want to flip a coin and get a head? No, it doesn't. It doesn't make any difference. Whatever I roll on that die, it's not going to change the probability of me getting a head. Okay, so tossing. Oh, I don't know what's happening. A coin. Okay, that's not going to change. So they are independent events. Something that we call dependent, so the opposite, is so what's an event that'll happen that will influence my next event. So something I thought of would be the probability of it raining. Okay, so the event of it raining, let's say there's 90% chance that it's going to rain. That's going to affect the probability of whether I have an umbrella with me or not. Okay, isn't it? So whether it's raining, it's going to affect what I wear. So clothing, it's going to affect what clothing I wear. So the event of it raining, okay, it does depend on what I wear. So these two are not independent. They are dependent on one another. Whereas these two, okay, they are independent. It doesn't matter what happens. It's not going to affect the probability. That looks very messy. Let's just try that again. Ooh. Roll a die or toss coin. Cool. Okay, so hopefully that makes sense to you. Now, to test whether two events are independent, we're going to look over here. If the outcome of one event does not change the probability of obtaining the other event, then these two rules apply. Okay, so for the first one, it says the probability of A given that B has happened should equal the probability of A. Okay, so if these two equal one another, that means they are independent. So remembering this one here, that's what we call our conditional probability. Hopefully you remember that. Let me write that. Conditional. Okay. Now that, remember, you need to get the... undo that. Whoops. So this conditional probability is you need to get the intersection of A and B and divide it by the A. Now, if that equals the probability of A, then that means it is independent. Okay, so that's what this one means. Okay, the other condition, let's do that one in blue. The other condition of whether two events are independent is if you have the probability of A intersect B, okay, the intersection, if that probability equals the probability of A times the probability of B, that means it's independent. Okay, so whatever this probability is, if it equals the same as the probability of A times B, that means it is independent. So we can do tests to see if that's true. These next couple of points, so for multi-stage experiments, so that means more than one. I'm going to sneeze. Excuse me. Where selection is made with replacement, okay, successive events are independent. Okay, so when you've got more than one thing happening, as long as you're replacing, the successive events will be independent. But if you are doing multi-stage events without replacement, then the other events are not independent. Okay, because if you're not replacing something, so you're choosing a red ball, you're taking the red ball out and you're not putting it back in, that does change, or it does influence or affect that next event. So that's why anything without replacement is not independent. Let's do an example to see if this will make better sense. Get the highlighter out. So we've got a selection of 10 mobile phone plans. A selection of 10 mobile phone plans includes 4 with free connection, 5 with free second battery. One plan has both free connection and free second battery. So let A be choosing a mobile phone plan with free connection, and let's go to colour. B can be choosing a mobile phone plan with a free second battery. Okay, so A says summarise the information about the 10 mobile phone plans in a Venn diagram. So, very important, which a few of you forgot in your progress quiz. Venn diagrams always need a rectangle. We have 2 events, so we can have 2 circles. And we've got A and we have B. Okay, the first thing to put into your Venn diagram is this intersection, okay, the middle of A and B. How many phone plans have both the free connection and the free second battery? It says 1 has both, so 1 goes in here. Okay, then we can go back to A. So A is mobile phone plans with free connection, and it says 4 have free connection. Okay, so this whole circle of A needs to add up to 4. We already have 1 in here, so this one's going to be 3. That's where a lot of you will get stumped with your Venn diagrams. B is choosing mobile phone plan with free second battery, and this says 5 of them have free second battery. Now again, so this whole circle of B needs to equal 5. We've already got 1 there, so we need to put 4. So 4 plus 1 is 5. Okay, are we done? We need to make sure we've accounted for all 10 mobile phone plans. If we add up these numbers, 3 plus 1 plus 4, that equals 8. Okay, so that must mean that 2, to make up to 10, of them don't come with a free connection or a free second battery. Okay, so you've got to make sure all your numbers add up to the total amount. So that's A. B, I asks us to find what's the probability of A. Okay, probability of A. So let's find, whoa, what happened? How many is in A here? Well, 3 plus 1, there's 4. Okay, 4 out of how many plans altogether? 10. Now, we need to make sure we simplify. So this will go to 2/5. Okay. Now the next one, I, it says find the probability of A given that B has occurred. Okay, this is your conditional probability. If you don't remember it, you need to go back to your notes to find the formula, and I did write it in that last slide. So we need to find A intersect B divided by how many is in A. B, because B is the last one here. Let me get rid of that. So the intersection of A and B, okay, we know is 1, and divide that by B, so the total amount in B, which is 5. Okay, now according to, I'm just going to flip back over here, okay, according to this little one here, it says that the probability of A given that B has occurred, it should equal the probability of A. So what C is asking us, it says state whether or not the events A and B are independent. So the probability of A is 2/5. The probability of A given that B happened is 1/5. Are they the same number? No, they're not. They are not equal. Okay, they have to be equal to say that they are independent, but because they're not, so we can say therefore events A and B are not independent. Okay? If they were equal, they would be independent.